Hello everyone, my name's Stephen Cropley and I will take you through this ramp balancing system that we have put on the web. It is available from our public site right now at geocounts.com and I'm going to take you through how to operate it. It's free to use and it is a very productive tool because you can add and save data for later and share it with colleagues. So I'll show you how to operate it. Briefly, if you haven't heard of traffic data used for ramp balancing, I'll just put you into the context of where we are. Traffic monitoring is performed to collect data that describes the use and performance of the roadway system. And from our perspective, network traffic data collected by departments of transportation and larger MPOs is sent monthly to the federal highways through a system called TMAS, and every year computing the whole network through HPMS. That is normally what we do as a business, but one particular aspect of it called ramp balancing is something that I'm going to show you today. There is all kinds of equipment and counting methods that is used that results in inconsistencies in traffic volume counts. There is continuous or permanent count stations recording the distribution and variation of traffic throughout the year, and short duration counts are performed to supplement these counts. All of these counting efforts are combined in this exercise that we're going to call that's called ramp balancing, which computes data on the network for where there is no possible count or counts are not easily obtained. So getting into this part of it, what is ramp balancing and what does it even mean? It means that along these access control facilities, you get inconsistencies in your traffic counts. You might have a permanent counter, which is the green balloons here, the green markers. They might be counting along your network, and then you have your ramps on and off the network, and you may discover that when you sum up or if you perform a computation of adding and subtracting ramp volumes, that it turns out that the values that you might compute do not equal the values that you have measured. And there is a need then to perform this thing called balancing. So to minimize the effects of these short duration counts, which typically are difficult to match up with your continuous counters, you perform this ramp balancing. You can also use it to estimate the traffic volumes at non-monitored roadway sections. That's the blue marker here. That's a point on the network where we want to estimate counts based on the continuous counter and the ramps on and off that we've monitored. So we do this ramp balancing in order to match up data that was collected at continuous counters and short-term counters on the ramps to estimate the midpoints where you could not count because it was either too dangerous or you didn't have a counter there, and in doing that we perform this analysis. All right, I'll just move this through. Okay, so here's how it works. We observe these traffic counts on the ramps and adjust them using mathematical optimization. And the objective is to make sure that the mainline counts at the top and the bottom, that's in the green, are the ground truth in this. So if you counted 23,000 vehicles at the top here, and at the bottom you counted 27,000 vehicles, then all the other counts along the route, no matter how many ramps you have on or off, they must balance so that those two values are met. So that if you were to take 23,000 and add 2,767 and subtract 961, etc. And you work down the main line, you should end up with a value that equals the bottom value of 27,000 by adding and subtracting the traffic. But of course, that's not going to happen because the counting is not completely accurate, and so you have to perform this optimization to work out what the real counts should be. And we use this value called the GEH formula, which I'll describe shortly. And that formula helps you verify how accurate your short-term counting was compared to the adjusted counts. The model we provide on the web is bi-directional, so it will compute both directions simultaneously, reducing the effort that you have to go through to compute these values. And that way your midpoint becomes a true AADT in the center of your analysis here, rather than a one-way AADT, but it will compute both sides and sum them up. So this GEH formula, a very useful statistic that was developed 30 years ago, maybe 40 years ago, and we have adopted it to help describe the error in the data. And so there's some sort of rules of thumb here. When the GEH value is 1, or less, you call that excellent. 2 to 1, it's good. If it's between 2 and 5, it's rubbish. It's acceptable, I should say. And if it's 5 to 10 or more, it becomes rubbish. All right. So I'm going to go through some examples. This one is on the web, and I will show that to you right here. When you go to this ramp balancing site, there is a quick start in the top right corner, and you can follow along at home, as they say, by doing what I'm doing. There's no server involved here. It's all done on your browser. So you can just click on an example, and I think it is number 2. Let's try this one. I think that's the one. So, so these are just some example points, and that have already been set up. I'll show you how to set those up shortly with a new one. But here you have all the points. You can click on the points, and you can see that it lights up where it corresponds to. So you can see where you are, etc. You can edit things if you wish. You can edit the example. It will not change the data. It will not change it for everybody. That's totally fine. It's all done in your browser. This online version is all on your browser. So you can make changes to that. And then just to kind of jump right to the interesting bit, when you hit this balance button like that, it computes all of the values that you want to use in your analysis. So it computes all the values for the ramps. So this count made the observed count for this station. Let's see, there it is. Zoom in here. So this ramp off, it was counted with the value 961, I should say. Sorry, that was so 961 vehicles were counted getting off the main line on this ramp. But when we balanced it to make sure that all the values make sense, we adjusted it to 733. Okay, so that's a difference of 228. And by plugging it into the GEH formula, it thinks that is acceptable. If you hover over that number there, you'll see what the GEH formula believes that change is. It's acceptable. So that's each of these ramps on and off, which you've counted, have been adjusted. And the important value, the one that you will want to, that you wanted to know, because this is why you're doing the ramp balancing for this particular segment of road, this value here of 25,689, that is your balanced value for the midpoint. So that's the number that you then say is a result of all of your ramp balancing effort, and that was computed based on all of these surrounding numbers. Okay, so that's an example, and you can do that. You can modify the numbers. For example, you could just, let's say we counted, instead of 961, we counted 990. Say okay. I'm just going to rebalance that, and it recomputes the numbers based on that information. You can, well, this is not a good example, but let's say there was a ramp off here. Let's just pretend there was a ramp off. You can click ramp off here and put that in, and now you've got another point. You need to move it into the analysis so that it matches where it is on the route. And if you hit balance again, of course, it's not going to do very much because I've counted nothing. But let's put in some numbers here. Let's just say 100 vehicles got off that ramp that didn't exist, but let's say it did. You hit balance and it recomputes those numbers based on that. So that's a quick example. You are welcome to experiment with this, to drop values on, and I might just show you a quick starting point. Let me just refresh this screen just to start from the beginning. All right, so now let's say we're in where are we? Let's pick Denver, Colorado. All right, I'm just picking a random interchange here, maybe something a little smaller to begin with. Let's just do here. All right. So I'm going to just start dropping some points on and do some analysis here. Just make stuff up as we go. So I'm going to put ramp on. There we go. So when you click on the very first point, it'll drop the anchor points in straight away. I'm just going to move them somewhere up the network. Let's just move it down here. All right. Let's assume we were counting at these 2 points, and I'm just going to put some ramps on and ramps off. So that one ramp on. Let's do another one here. This one's ramp. That one's ramp off. If I make a mistake, I can toggle it. There we go. I can just click here and it will switch it to ramp off. I'll put a couple more in. That one's ramp on. Let's turn a ramp off in here. There we go. Now I want to put in a midpoint. Just drop a point in there. I'll do a couple more. Ramp on, ramp off. So ramp off here and a ramp on there. Okay, so now I've set up the analysis network, or I've put the counters on. Now, so in this example, I'm just going to make up some numbers just to drive the analysis to show you how to get to the finish line. Of course, you will have your own numbers, and you can plug them in yourself. So let's just say there were 20,000 vehicles on that, and let's go to the bottom here and say there were 18,000. And ramp off. Say 1,000 got off here. Oops. And 800 got on here. And 1,200 got off. And 750 got on. I'm just making these up, but you'll have your own numbers. Okay, now the last thing that we want to do here to make it oh, I may have, if I missed a couple, may have missed a few. Oh yeah, I missed the top section. Let's do a few of these. Sorry. Let's put this one. Let's make that 1,000, 1,200. There we go. And last one, 690. There we go. Okay. So now they all have values. I see no red numbers in my entries, so they've all got something. I can just go ahead and hit balance to see what that says. And given that I made these numbers up, it's not surprising to find that one of these has a significant error in it, that the model thinks that it was not a very good count at all. So it's made a big adjustment to that particular one. So that's an example of how it works. One thing I actually forgot to do was I forgot to put the analysis direction. So it does work in both directions, but I should have said that I'm analyzing analyzing southbound. So that may be a reason why my numbers aren't working. So this is south. This one's heading north. Apologies, I should have done this at the beginning. This one is going south. This one is heading north. There we go. This one is north. This one is south. This one is south. And this one is north. All right, let's balance again. Okay, now my numbers come out a little better. I apologize, I'd forgotten the important step of telling the model which direction the ramps are going, north or south. I did say it was bidirectional, but it has now computed the numbers and come up with balanced values. And at this point, as we're getting close to the end of this very short workshop, you can now save that information. You can do this. You can save it as JSON data, it's called. I can give it a better name. So, example for webinar. Here we go. And I'll just I can save that. Let's export that. Oops, apologies. There we go. Okay, so that has exported. So I've now saved it to my disk. I can come back in the future and save that. Sorry, it popped up on my other screen. That's the data as JSON data. That's now saved to my disk, and I can open that again later, or I could send it to a friend or a colleague to investigate and analyze that. And the last thing to show you that is, so for example, if you wanted to upload a file, here we go. I've got one here that I created earlier. This one's sent in from Hawaii DOT. Thank you very much. As an example, so I can import that JSON data, and it will show me that model that represents the interchange in Hawaii. That's a very nice place to go for a ramp balancing exercise. Perhaps we all need to move there to investigate the ramp conditions in Hawaii. But that's an example of saving your work and opening it again, and you are welcome to do that. Okay, so we promised this would be a short webinar. That is the whole process end to end. as we say, you are welcome to do this. This is free online to use. You can't save data to our database. That's the product we sell, but you can certainly operate this yourself and if you need help, you can just send it to us for assistance. And we'd certainly love to learn your experiences using it. I will take any questions if there are any either presented in the chat or by phone. Dan, have we got any questions at all in chat? And I'll just stand by for a minute or two to see if you have any. You want to ask me a question about this?
Yeah, another question, Stephen, for you is: if you don't want to put in all your markets manually, do we have spreadsheets? We have a spreadsheet available as well. Do you want to show that?
We do have a spreadsheet. Thank you for that reminder. It is on the up. No,
paste file.
See. Paste file. Thank you. Right. Yes. On paste file, there is a ramp balancing spreadsheet. This may go beyond the scope of this webinar, but this allows you to create. If you have an input, you create it on your spreadsheet. It'll take a few minutes for you to figure this out, but it allows you to build the ramps. And when you're done, you save everything. I'm just going to hit Control C to copy it to my spreadsheet, and I'm going to paste it in and hit Import, and we'll see the data that was created there for that. So you can bring data in from your spreadsheet if that's the way you've got it. But of course you'll need coordinates but you can do it that way as well. All right, guys. Thank you, everybody.